Okay, we should be live now. Hello, everybody. Hope you can hear us and see us well. Yesterday we had some problems with the sound. Hopefully today that's not gonna happen. We think we solved the problem with the static noise that we had from yesterday. So now just again, do you hear us well? If yes, let us know in the comments, and then we're gonna get going slowly. We have some, let's hope. We have some familiar faces from yesterday as well. Walter, Richard, happy times. Yagadish, hello guys. And okay, all right, sounds good, cool. So today is gonna be the last. Yeah, the issue was I had too many devices which were connecting to the audio. So I had to disable some of those devices because, for example, my monitors were also responsible for the audio and also some other equipment that I have. So I had to simply disable all of that because that was interfering with the main hub we are using for the microphone. So that was the problem. Hopefully. So let's see in 1 hour. Yesterday I actually tested this. I had like a unlisted stream just to test the noise because usually the noise was happening between 20th minute and 30th minute, something like this. So now that should be all gone, but we'll see. So yeah, we're not gonna go too much into the details. Lazar is gonna take over right away, and yeah, enjoy, guys. So before we move on, yesterday at the end of the stream, when I tried to change the parameters, in some point the glass, all the glass surfaces disappear at some angle. So maybe I can show you now what I mean. So we'll fix this issue, and after that we're going to move on. So this is a Grasshopper script that we finished yesterday, and let me show you. If I change some of these sliders, you can see that now all the surfaces, all the facade surfaces disappear, and they disappear because they have different index. I mean, the lines or the NURBS that we use to create those surfaces, they have like different indices. And here we chose some indices, and I mean, they're different in this case. So our idea is to create uniform Grasshopper script, no matter of rotation or the position of the base plane. So you can see if you rotate base plane, some of the indices like are changed. And let me show you why. It is here when we, in this part, when we sort NURBS, so in the group that I call sort NURBS order inside each branch. So if you remember here, so I added this part, so let me delete. Remember that we use circle fit to sort points. So let me show you here. So here we have all the NURBS, and I extracted endpoints, and based on the endpoints inside each branch, we created circle fit, and based on these circles we sorted points, and these indices we use to sort NURBS. But the way how the circle fit, these circles are generated, we cannot control. So sometimes this, because you can see here that I use first list or first item from the list to flip the curves, to flip the circles. Which means based on the circle at index 0, based on this direction, we sort all the points, and later on we sort the nerves. But what I want to say, we cannot control what will be the direction of that first item. So sometimes, if we rotate, if we set like in the case that we had yesterday, I set rotation degree here was 30 degrees. It was one direction. Let me just find. Yeah, it was one direction, but if we set like 40 degrees, it was opposite direction. So we need to find a way how to uniform. So every time to have like the same, no matter which angle we choose, it will be the same direction of that circle, that guide circle. So I'm not going to use this circle fit. So I'm going to create another circle based on this one. I will extract center point, and I will type a circle. I will take the same radius. So don't forget to flatten this one, as we have also flatten the circles. Here we have center, all the centers, and we need to create base plane. So base plane will be our base plane that we have. So this one. And we just need to set origin. So all of these circles now have like the same base plane. I'm just going to move this on the right. Okay. And now these circles I will use as I will use to sort along, and I will use first item as a guide curve, right? And based on these indices, we are going to create facade. So we just need to tweak indices here once again. So sorry for that. I will quickly go through this part. Once again, let's focus first on this part. Actually, where is it? First, I will use blob outline. I don't know how to pronounce this one. Blob, I guess. Blob outline. And let's focus on these guys. Okay. So now we are not going to use index 0. I'm going to use let me find it. Where is it? The main one. It's here. So let's focus on the right one. So here I will take this edge. So this edge has a different index, so we need to change this index. It has index 0. And also we need to change these two indices, this one and this one, for the left side. Now we need to take maybe I should rotate another side. Let me just take a look. I just want to make sure that we pick the right. So we need to take that, yeah, that one. And now we should select this guy and this one. Okay. Okay. No, not one. Should be. Let me just check. So yeah, we just need to select like correct edge. Okay, I'm going to visualize this first. On the right side, I'm going to select index 0, yeah, that one. On the right side, 1 and 2. I will just double check. Let's check once again. Look at the right facade. Never mind. Sorry, just need to make sure that we have the right. So let's take a look from here. This one. So here. Yeah, we need to have this one. And here we take this guy and the one on the inside. Okay. So as I said, inside, which is 3, this guy. And on the right side, we should select this one and the other one that we don't see from this angle. So index 3, and here we have index, let me check if I select correctly, index 0, index 1. What we get here, yeah, okay. So here we have 0 and 1. This is the curve that we get if we make if we join these two with transition that we made yesterday, and we made like, okay, we created one side. On another side will be on opposite. So let's select this one that doesn't have any transition. So it should be this guy here. Index 1. And here should be okay, let's go back here. Let's go to see the index 0 and 3. Okay, where did I see 0 and 3? I saw it here. So these two, 0 and 3. These two items we need. Okay, and let's do the same for the second pair of second set of glass surfaces. Also, we need to change the indices.
This part, let's select these two guys. So here we have curves on the bottom. So we need to change here. I will select starting point. Let's visualize. And I'm going to make this transparent. Okay. So here we need 0 and 1. 0 and 1, you can see here, 0 and 1. And here we have 3 and 0. Just check once again. 3 and 0, yeah. Okay, I didn't turn this. Zero and 3. Weird. Okay, let's select this. Ah, sorry. This is for the top surface. Here we should select 0 and 3. My mistake. Okay. And this is the surfaces on the top. And here we should select, if you remember, 1 and 3. Let's see. 1, 3, and 1. Okay. So we fix the issue that we have. How are you keeping the point numbers visible? How are you keeping point numbers visible? You mean this one? I got this this path and no, they are not baked. I just turn them on the preview. So I enter them on here. If you mean this one. So you can, I took it from here. So basically these are all the NURBS, and here we have start point and end point. I took because I was creating these surfaces, so I had to see what is the bottom, what is the index of the bottom of the NURBS. So I took start point and I you know, connected with the parent viewer and click on the preview. This is like super useful when we need, you know, when we need to know the index number. So if we, as I said, if you want to create a surface between this edge and this edge, here we can see like their index. Okay, so we made now our Grasshopper script universal. Let me show you if I change the angle now. So no matter which angle we choose, we'll still have like all the surfaces visible. They will not disappear. Rhino 8 version 8 doesn't have the function. Yeah, it doesn't have. It comes with Rhino 8.12. You mean to show this one? Okay. Chat. Rhino 8 version 8 doesn't have the function. Yes, as I said, it comes with Rhino 8 service release, I think 12. So if we have, I mean, if we have legal version of Rhino, just update. I really hope that you have legal version of Rhino. Okay. And So I can show you once again how we can tweak these sliders. So this is about the height, but we have, yeah, here we can, you know, change the dimension of the vertical facade elements. So here we have, you know, width and length. What we have here, yeah, here we can change the gap. All right. Here we can change the number of elements. Okay, let's set it back to 7. Okay, so do you want me to zoom in for you just to see all the indices that I changed? Can you like feel free to tell me if you want me like to wait a couple of more minutes? Okay. All right. So here we choose index 3. If you like, Walter, I think you have our version, I know our Grasshopper version that I publish on our premium How to Rhino. So make sure that you set index 3 at the top. And here we have index 2, index 0 and index 1. So 3, and here we have pair of indices 0 and 1. And here we have index 1 and pairs 0 and 3. So once again, 3, 0, 1, here 1, 0, 3, and for the another set of surfaces we have 0, 1, 3, 0, and 3, 1. Okay. If I place them all into one data tree, you can see that we have some null items. So I will use clean tree, right click on E input and set true. Sorry, set to you just need to make it to invert the default, because by default it was set to let me just, what was set? It was set to true. I mean, you don't need, because we are removing null, we are not removing empty. So after that, if I calculate the area of each, some of these surfaces are like super tiny, so I'm going to remove them. So I'm going to calculate, so if the area is larger than, let's say, 0.001, I want to keep that area, otherwise they will be removed from the list. Let me just show you which are these. So you can see here we have like surface as a line. So it's like, instead of like having like surface, we have just a line, because we created surface between NURBS index 3 and NURBS index 1, and they're overlapping. That's why I don't want to have this guy on the corner. So here it's okay, but on these two opposite corners we have these tiny surfaces. So I want to remove them. Okay. And we finish with the glass part. Now let's make the top part. Okay. So I will open the sketch to show you what we're going to make. So this is what we created so far. Our idea for today is to create these elements on the top, to also add glass on the top. And really important step is to merge glass surfaces. So from this step to this step. Why? Because I want to have like a single surface, and based on this single surface we'll take the outline, and based on the outlines we'll create frames. Otherwise, if we don't merge them, we'll have this horizontal frame that we don't need. So that's why we need to merge glass surfaces, and after that we're going to create frames. So we need to offset all the glass surfaces and then to add frames. So what we need to do now? We need to extract all top surfaces of the vertical facade elements. So this is the first step. And when we extract them, they will be placed in this data structure as we have here. So same color represent surfaces that are placed in the same branch. If you remember, this comes from the data structure when we created pairs of branches. So these two will be in the same branch, these two will be like the same branch pair, these two, and so on. But I want to create this kind of elements, which means, for example, this surface and this surface should be in the same branch. This one and this one in the same branch. So it should look like this. So once again, we need to change data structure. Okay, so first let's extract, our next step is to extract only these top surfaces. So I'm going to take these curves. Let Let me move it here. Once again, these curves that are created using path mapper, this one, not the second one, because in this case, this one, this element, and this element are, I mean, these two are in the same branch. Okay. And I mean, we already created, maybe we can just copy this part. All right. Let's turn this off. And there is component edge from face, this one. So what it does, we're going to create all edges. We're going to create all edges based on the point, based, let me explain. So we're going to position point on the B rep, and where this point is placed on which face, all the edges of the face will be selected. Okay, so we need points for face coincidence check. These points we can get if we take, let's say we will take endpoints of the curves. And I will find the average inside each branch. So this will be the center. So if we have this point, these 4 points, this will be the average. Okay. And I will place this point here, which means if we have a like B rep, we take this point, which means this point is placed on this face, and edges these 4 edges will be extracted. And I'm going to join them. Once we join, we can merge these two. Let me just check data tree. Right now we have 56 branches. Inside each branch single item, but if I trim tree, we'll have 28 branches. Inside each branch 2 items. And let's visualize, let's say first branch, items in the first branch. So we have these 2, then we have these 2, and so on. What we want now, I want to merge, so I want to create region union between these 2. So instead of having like this, instead of having 2 rectangles, I want to create 1 rectangle, like that. So I will use region union. Perfect. And we managed to extract the surfaces from the sketch. Now we need to change the data structure from this to this. I will zoom this out for you to follow along. So now let's make pairs of rectangles like that, like this on the, like you see on the sketch. So what I'm going to do, I will find the center here. I will create circle fit, and I'm going to sort these rectangles. Not circle fit. My mistake. Sorry. We are going to create to find the center, and this center will be origin of base plane that we call base plane in our Grasshopper script. So this is X, this is Y, and center of these rectangles we are going to how it's called, we're going to use plane closest point in order to get local UV coordinates of this point, of the point that I just sketched on this plane. Once we get UV coordinates, I'm going to sort all the points based on their Y value. And for example, these two will have the same Y value. These two will have the same Y value. So once we get the list of all the points, we'll then use list partition to say, okay, list partition that the length of the branch will be 2. So these two will be in the same, then next two will be in another branch, the next two will be in the third branch, and so on. So this is the logic. Can you show where you pull the curve from again? Yes, okay. Once again, I pull from here. So either from here or you can pull from here. So I will take pairs of, branch pairs. I can show you a screenshot. So do you remember when, so yesterday when we created this? So from this data structure, I pulled the curves. Okay. After, so as I said, like, let's turn this off. I will extract the center. Let's flatten all the centers and I will find average. So this is average point, and this average point will be origin of the plane, and base plane will be our base plane. Okay. And the next step, we want to use plane closest point to find the UV coordinates of the local coordinate system. So here we should place the plane. Here we should place the sample points. And here we have the UV coordinates. So I'm going to sort this surface based on the Y coordinate of the UV coordinates on the plane. But we cannot sort if we don't flatten them. So we need to flatten them first because they need to be placed in the same list. Now when they're sorted, I'm going to sort. So maybe we can, let me just think, we can flatten also this one. We don't need flatten here. I mean, we don't need to flatten 2 times. And let's sort the surfaces based on the y coordinate. So here you can see how the y coordinates are sorted, and now we can create pairs of items. So this pair will be in the branch 0, branch 1, branch 2. So let's create a list partition. So I will take surfaces, and the size of partition will be 2. Let's turn this off. And let's see what we have inside the branches. In the branch 0, we have these 2. The branch 1. Let me just turn off. This makes confusion. I'll turn off this for now. I'm trying to find the best way to visualize. No, this is not the best way. Let's delete. Never mind. It can be transferred a little bit. Okay. And now we have like proper data structure. Can you follow along? Thanks. I think that's why, I mean, on these live sessions, we try to show you as many tricks as possible to sort data tree and to sort data tree, to sort branches, items, to how to manipulate, how to adjust with the path mapper. So I think, I mean, that's why I told you at the beginning, the final result is not important as the whole process. So the whole tips and tricks that you're going to learn along the way. So if you understand all of this, I mean, I think it will be super beneficial to implement in your everyday work with Grasshopper. Yes, you're following along. Okay, great. Now I want to select only one part of this. So I want to select only half of this. Only this part I'm going to select. So only these surfaces inside this region. And the rest, because why I want to select just one part, I will focus just on this part because based on this one, we can create this facade elements. And once we finish with that, we can just mirror it on other side. So let's select only half of the pads. So right now we have 14, but I just want to select half of them. So here we have the branch count, number of paths and branches in the tree. And this number I'm going to divide divide by 2. So only 7 branches we're going to select. I mean, that number, of course, you can take from here when we multiply elements. So this is the same number. So you can take only this number and plug it there. Once we get that number 7, I will use component list, it's called split list, this one. So I will use index 7 to split this list, and only first branch we're going to select. So only this part we're going to select. We don't need the other one. So I will use this path to select. So I will use tree branch. And let's select, so only this part we'll take, and we'll work on this part. Once we finish, we will you can either just rotate or mirror, it's up to you. In the next step, I want to deconstruct corner points of each surface, and I want to sort their items. So it is really important to every time to sort the items. If your logic is based on the items, so if you select like particular items with the list item, before choosing that item, make sure to sort that list properly, and that list will not be changed. If you modified something before, that list or that items will stay the same no matter what you do before. So remember that the problem that we had here, because we didn't make our Grasshopper script universal. So later I will my logic will be based on the particular items. What I want to do later, I will take this point and this point. I'm going to move them up, and I will create this rectangle, and I will take this point, this point I will move up and create this kind of rectangle. But I want to select these particular items, and to select them first I need to make sure that I sort them properly. So once again, I'm going to use circle fit. Not this one. Fit. And this time I will not forget to use base plane and to generate a new circle. So the same logic. Plane is pure origin. Okay. And these circles I will use to sort control points, so the polylines. Points, curve to sort along. And let's visualize. You can visualize, I mean, once again, you can use parent viewer, or you can use text point list or text tag. It's up to you. Let's use point list. Okay, so you can see the same order of the points inside. Let me show you how it was before. Actually, the order was the same, but I'm afraid if we rotate something that it will be, some of the items will be changed. So I just want to double check that I sort them properly. Okay, now I'm going to select item 1 and item 0. Actually, no. First, I want to place these 4 points inside the same branch. So this will be one branch. This will be second branch of points, third, so on. So we need to, I'm going to simplify, and I'm going to trim 3. Okay. And now I want to select 1 and 4. Let me just check. Maybe we should first trim 3. Yeah, that's my mistake. So first we need to trim 3 and position these 4, actually these 2 set of 4 points inside one branch, and then I should sort them. Yeah, sorry. So first let's simplify, and now I'm going to trim. Okay, now it's correct. So you can see how the points inside each branch are, I mean, they have the same distribution. So this is 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, and so on. So now it's okay. Did you understand why I had to trim 3 first and then to sort them? Okay. Now let's select items 0 and 3 because I'm going to move them, and I will create this polyline. I will select items 4 and 7 and create another polyline. Maybe I prepare some sketches here. Let me check. Yes. So this is our idea. I'm going to later to fillet them, offset them inside, create surfaces, and their naked points I'm going to loft in order to create 3D shape. So that's why I'm going to select these 4 points. So we need 0 and 3 and 7 and 4. So make sure to have like the same order. So I'm going to use list item, and instead of, you can either use slider from 0 to 7 and pick the items, or you can zoom in here and extract all the items. We have items from 0 to 7. And now let's merge. So I'll take 0 and 3. So I will select them in the same order. So 0, 3, 4, 7. So 7, 4, my mistake, once again. 0, 3, 7, 4. 7, 4. Okay. After this, I'm going to move them. I'm going to move them up, but maybe we can see from some of these sketches. Actually, I'm going to open Final Script to show you what I want to get. So you can see here that this front one should be higher than the inner one. So this polyline should be higher than this one. This is outer, this is inner. So let's use unit Z to move this one. Let's select 5. This is inner. And outer can be, we can use addition. So 5 plus slider, value that we choose here. Let's say 4. And that will be amplitude to move items 4 and 7. Okay. And now I want to create polyline starting from here. So this will be index 0, index 1, index 2, index 3. So this order. Sorry. This one, and this one. So 0, 1, 2, 3. Like this. What we can do, I will take these guys and I will use a weave component. So weave, and I want to merge these two sets, right? These two pairs. In total, we should have 4. 2 from here and 2 from here. So here we have bottom, and here we have top curve, top points. But we need to define the pattern. First, I will take point from the bottom, so which means the first number in the pattern will be 0. Then I'm going to take 1 point from the top, again 1 point from the top, and then 1 point from the bottom. This is how we can find the order, how these two sets of points will be merged. And let's see what we get. If I create polyline, okay. Same logic for another set. My mistake here, I forgot to connect this new vector. So vector 9, I mean vector z with the value 9, with amplitude 9. Okay. I'm going to stop here for you to make sure that you follow along. Yeah, how's the sound? Dushan asked, how's the sound? It sounds great. It's great today. Seems like you fixed the issue, but yeah, I don't want to jinx it. Much, yeah. Fabulous. Do you want to check something?
Yeah, I just wanted to let you know, guys. So once we finish the session today, we're gonna have like a special video that we're gonna publish, which is gonna come probably maybe next week. That is gonna be like all these 3 sessions combined into one video. And we managed to fix the sound from yesterday's session. So we're gonna try to like put all these 3 sessions in one big video. And that's something that you can expect to see next week. It's gonna be a little bit different than these sessions. We're gonna kind of cut out the pauses. So it's gonna be more fluid. So you can also watch that on the channel when if you wanna go over all of this again. So that's what I want to mention.
We have a comment from Sergey. You have to correct height of second pair. We don't want to correct height because I want to have like different height. I just explain why. Let me open the final. So I want to have this kind of shape on the top. So I want to have 2 different heights, if you know what I mean. So that's why we have 2 different heights. And also regarding the final video, we're going to, with that final video, we also I'm gonna publish on school all these sketches that I was keep showing you with the steps. So all these sketches we'll try to put on the same page and with the timestamps, like at which part of the video, what part of the project we're doing at that moment. Hope that makes sense. Okay, now I will take this set of polylines and this set of polylines, and I will place in the same data tree. So we'll take Antwine. I will remove branch 0, 2, and I will merge them. This time I will not uncheck flatten inputs. And in the next step, I want to fillet these polylines. So I will type fillet. In the radius of fillet, we can take this value here, and we can multiply with certain factor. I mean, this is up to you how you want to fillet these curves. It will be based on this factor. So I will take the height of the the lower polyline, and I will multiply with the factor with the multiplier from 0 to 1. Okay, Sergey. Yeah, I forgot to connect the height, previously. Yeah, okay. You're right. Okay, so we fillet this one. Maybe fillet is too big right now. Okay. Can you consider making a video about careers in parametric design? You already answered about that.
Yeah, that can be interesting.
Yeah. Sorry, I need to drink more water. Yes, Sergey, I understood what you mean, yeah. Okay, now in the next step, I want to offset inside. So I will take all these curves and I want to create them inside like this. But we need to find what will be that offset factor. So I will type offset curve. This will be offset curve. And offset distance, you might say, okay, offset distance is the same as width that we created at the beginning here, right? This is width. Maybe I can reference it here and call it vertical facade element, facade width. And I will switch to text. And I'm going to wire display to, I will choose hidden. And you may say, okay, this should be the offset distance, but there is one step in between. So if I connect this one and switch to negative, you will see that it should be larger. I want to ask you, do you have idea for how much and how we can fix this one? Why it should be large? Why it's not the same as width of the rectangular? Why it's not the same as number 1? Why it should be larger? Anyone have idea? I will wait few seconds if you don't know or why, I'm going to explain you. I just want to interact with you more. No, I mean, if you rotate the length is the same. Rotation, it's not related with the length. Yeah, plane, it's not related with the length of the line. We just need somehow to increase this length. Anyone else? Stretch part. No, but you're close. I think that part was after stretching. Let me check. No, or it was before. Scale part. That you're correct. Yes, because you remember that we took polylines at height 5 and height 4 and we scaled them. So where is the part where we scale it? Yeah, top power scale. That you're correct. So this adjusting control. Yeah. So we need to scale these rectangles by 1.3. So I will take this scaling factor. Maybe we can you can either create remote sender and remote receiver, or you can take what I did with the width. So I will take this one, scaling factor. So let's take this one, and I will multiply with the vertical facade element width. Now let's see. Now it's correct. Now it's matching. Okay. So now let's place them in the same branch, but make sure to have the same data structure. So now here we have 2 branches with the 7 items inside each branch, and here we have 14 branches. But if you just find the width of the top rectangles you just created, yes, you can do you can do that as well. Yeah, this is also okay. So we can graft this one, and I'm going to merge them. Now let's see what we have. We have 14 branches. I'm going to simplify this for you. So we have 14 branches, and inside each branch we have 2 items. But let me show you which 2 items we have. So in the branch 0, we have these 2 items. The branch 0, in the branch 01, we have these 2. But our idea, let me show you what is our idea. I want to have data structure where this is 0, 0, and this is 0, 1. Because I want to create geometry between these guys. I want to use these 4 polyline, these 4 curves to generate PREP. So that's why we need to we need to adjust data tree. Let me show you what we need to do. So I'm going to use how it's called, shift paths, and I want to use positive value to remove this one. So we have only two. Actually, let me just double check. If we use trim tree, we will have two items. But I want to, my mistake, I want to remove this part and have branches from 0 to 6. So basically, this one and this one will be in the same. This one and this one will be in the same. This is what we need. I'm going to show you once again. So 0, 0 and 1, 0 should be in the same branch. So we cannot do that with a trim tree. We can do that with the shift paths. And here I will use positive 1. Minus 1, if you use minus 1, we'll get the same as trim tree with the positive value, positive 1. But if we set positive 1 into offset, we'll have 7 branches. And let me show you what we have in the branch 1, in the branch 0. In the branch 0, we have these 4 guys. So 0, branch 1, branch 2, branch 3, and so on. Okay, I will delete this one, delete this one. Okay, but yes, we can also do that. And in the next step, I want to separate. So I want to have this and this one. So these two curves, one branch, so 0, 0. These two branch 0, 1. Simply, we can use once again partition list. So right now we have 7 branches inside 4 items. But if we divide each branch, if we separate each branch in 2 sub branches, this is what we'll get. So 0, 0, 0, 1, 1, 0, 1, 1. Okay. Next step, we'll create first loft between these surfaces. So I'm going to create loft. And once you create loft, I will extract their naked edges and create 3D BREP. BREP is always 3D. What Jagadish said here, so we can use path mapper. Right click, create null, and we can switch B. No, sorry. No, we cannot do like this one. So from this one, we should get this. Yes. So we just need to switch B and A. You can see the position A, position B. So main branch level is switched with the second branch level. And now, I mean, with the path mapper, you can get the same as with these two components. Now I will extract naked edges, join them. So I will use brep edges, join naked edges, simplify data tree. So try to keep checking your data tree. Bro, I came yesterday. I thought you were done, but still, no, we're still not done. Sorry, because we still didn't finish everything yesterday. We'll need to create the top part. Okay, so in order to loft naked edges, we need to trim the trim tree. Let's check data tree now. Let's see what we have in the branch 0. Okay. And now we can use loft. All right. Let's just create brep. Okay, I'm going to merge. Let's check data tree. Okay, this is correct. 7 branches inside each branch, 7 items, and now we can join. Brep join. Okay, this part is done. And let's mirror it. I mean, you can also rotate. Let's rotate. Rotate by 180 degrees, or you can use just pi. So angle, and now rotation plane. Rotation plane, it's really important to set origin or the base plane correctly. Original base plane is center. I mean, you can there are many ways to set origin, but remember here when we created this base plane, after creating region union, and we sort all the surfaces from the region union, we created this average, this center. So I will take this center, or maybe this plane, and use as a rotation plane. We'll type here plane. For all of you who are not sure of which plane I'm talking about, remember here when we extracted edges, then created region unions and sorted region unions, and we use this plane. So I'll type here rotation plane, right click, select text, and this plane I'll go here, bar display, hidden, plane. Let's see. Okay. I'm going to place them in the same data tree. Remove 0, 1. And we get the top part of the facade. And we need to create glasses on the top. And probably one of the most difficult part for today's session will be how to merge glasses on the top that we're going to create with the glasses that we already created. We're going to do that part after the short break. So we're going to make a short break 10 minutes. So see you in 10 minutes, so 37. I will keep this open for all of you who want to check. Okay, we are back. Let me turn off short break label. Okay. The next step, we'll create glass surfaces. So we need to create glass surface in this part. Here. Also here. Maybe that will be more visible if I turn off transparency. Okay. Let's go back to the step where we have curves. So I will use these curves to organize them in the proper data structure and then use our loft. So I'll take this set of curves from the partition list and I'm going to trim tree. And after we trim tree, we have 7 branches. Let's see what we have in each branch. So these are the curves in the branch 0. So all the curves that we have right now are which word is are corresponding with the B-rep that we created. So these 4 we have in the branch 0, then these 4 in the branch 1, these 4 in the branch 2. Okay, first I want to create this small surface. This one. I want to fill first this gap. For the rest, we need to find the logic how to fill all these gaps. So we can either select branch 0 and find that curve, or you can select or you can like flatten all the branches and pick that particular item. Let's do that. So I'm going to flatten the list and let's pick that item. Pick this curve. Okay, that curve has index 3. So I will take this curve. I'm going to find endpoints. I will create a line. That line I will join with this curve, and we can use simply boundary surface. So we'll type endpoints, create line. Merge with curve. And then I'm going to join. And I will use boundary surface. So we filled first gap. But now we need to find the logic how to fill all the other gaps. Let's turn off this. I will extract middle point to visualize first index numbers. Or maybe we can just simply use parent viewer. I will make this transparent. Okay, so what we need to take item 0 from the first branch. This is item 0 from the first branch. And I want to loft with item 3 from the next branch. So 0 and 3. 0 from one branch, 3 from the next branch. Right. So I'm going to select here items 0 and 3. So list item. Okay. We have 0 and we have items 3. I will flatten them. First, before flatten, I want to show you what is our idea. I want to make a list from these curves and a separate list from these curves. So that's why let's say flatten list 1, list 2. And I want to remove. So let's take a look at this list. I want to remove first item from this list, which is, maybe we can visualize now. Let's visualize them. So I don't want to loft 0 with 0. I want to loft 0 with 1. Then 1 with 2, 2 with 3. So we can take this list, remove last item, because we don't need last item to fill any gaps. Last item that we need from this list is index 5, this list, this curve. And from the other list, list B, we need last item, but we don't need first item. We already create a surface here. So you can either use cal index to remove first item from the list B and last item from the list A, or you can use shift list. So I want to, let me move this. I will take this list and I will shift by -1. Wrap should be set to false. So I'm going to place it false, which means we don't want to wrap this. Once we shift, we don't want to wrap it around. So if we set -1, we remove the last item. You can see that we don't have last item anymore. And the same thing I want to do for the list B, but I don't want to shift by 1. I want to -1. I don't want to shift by -1. I want to shift. I want to use shift offset 1. If we use shift offset 1, the first item in the list will be removed. So this is a new list. Let's visualize these points. So this is index 0. This is index 0. Index 1, index 1. Index 2, index 2. After that, we can graft, we can merge, and you can see inside each branch we have 2 items. And if we loft, we'll fill these gaps with a glass surface. After this, we are going to merge these two lists. You can either use entwine or let's use entwine. Entwine 0, this will be 1. Let's flatten the list. Turn this off. And I'm going to rotate same angle and same rotation plane. And we created surface on another side. And let's place them in the same data tree. Remove index, remove branch 2. And we have all the glass surfaces on the top. I didn't make groups here. Maybe I can do it now. But before that, I'm going to open the script for you to make sure that you did the same thing. Okay. Let's create groups briefly. So in this part, here we can call create top curves. This part here, create top facade element, and here we created top facade glass, top glass facade. And I'm going to merge facade that we got here. So I'm going to remove this from the group. Take these glasses, this one. Let's flatten it. Okay, so turn this off. I'm going to turn off this as well. And this one as well. Okay. We are getting there. Now we need to join this. I mean, we can, of course, we can, use brep join, but I want to remove this edge. So instead of having I want to have single surface. I don't want to have double surface. here, I mean, in this part here, we'll have 2 surfaces, but here we have 1, 2, 3 here as well. 1, 2, 3. I want to have like only one surface. Okay. So here we'll use brep join, but before we join them, I will use where is it? Data dam, this component. These components help us to, if we tweak the sliders. So imagine, because after this we're going to create facades, and we'll have some quite heavy grasshopper components such as split surface, and split surface sometimes require time to split the surface, and we don't want to wait every time. If we tweak some slider, we don't want to wait for our PC to run and to split the surface every time. We just need, for that we are going to use data dam. So which, once we finish with modification, now we can click play and then it will be split. It will, how to explain? I'm not sure I explained this well. So what is on the left side on data dam cannot be calculated what is after, so what is on the right side of data dam until we click play. So basically it blocks calculations until we click play. It will make sense later. Okay. So here we created, we joined top part with bottom part of the surface of the glass. And we got here either surface or B-reps. If we get surface, we'll keep it like that. So surfaces we have in this area. So this is surface, but this is B-rep. This is B-rep. This is surface. And this is surface. So I want to separate them in 2 different lists. For that, we can use match text and check if inside the text we have word brep. Sorry, it should be in the wildcard pattern for matching. And we get true and false. I will use this patch to be a pattern. So in the A, we have B-wrap. So here we have B-wrap. And here we have surfaces. We'll keep surfaces like this, but we need to merge. I want to get surface from the B-wrap. This is our idea here. So let me explain you the logic behind. I didn't prepare sketches, so I hope you will understand. First, I will extract naked edges. So naked edges of the B-rep. So this is naked edge, and this is naked edge. So I want to extract naked edges. this is the first step. Let's take brep and let's use brep edges, and let's extract only naked edges. We need naked edges, right? And I'm going to join naked edges. So we get 14 closed curves. And you may wonder, okay, why you just don't use discontinuity, like discontinuity points, to split this closed curve where one curve, this is terrible sketch, where the outer curve will be 1 and inner curve will be second, and between these two we can create loft or rule surface. But the problem is with this part, with the front brep. So that's why I'm going to use another logic that will be applied to all surfaces. The software is called LightShot. So anyone know what software is using to sketch over screen? The software is called LightShot. Okay, let's go back. So yeah, Dushan sends link here to download. Okay, I will use following logic. First, all these closed curves I'm going to split using mirror plane that we used before, if you remember. Mirror plane, this mirror plane. I'm going to split all curves. So this will be one curve. So one curve will be placed on the left side, and we will have curve on the right side. And for the front part will be easy. Just we'll have left curve, right curve, and we will load them. But now the problem will be with the others. Let's first use split. So plane curve, plane interplay with the curve, curve interplay with the plane. So this is plane, this is curve, sorry, and we need to find mirror plane. Mirror plane is somewhere here. Mirror, I think is this one. Mirror plane 1, yeah. So we're going to use mirror plane 1. Mirror plane 1. And we managed to split closed curves. And I'm going to use shatter. Okay. So let's see what we have inside. On the front part, we should have 2 curves, but we have 3 curves. Let's see why. Let's calculate the length. We got one super tiny curve, which we're going to remove. So I will calculate length of these curves. And I will say if the length is larger than 0.001, like this. So only these lines we will keep. Let's check what is that tiny curve. Where is it? I mean, we cannot see, it's too small. Never mind. Okay, let's go back. I'm going to delete this one. And let's see what we have. Basically, inside each branch, we have two curves, left and right. What is our idea? I want to take, once again, terrible sketch. I want to take a left curve, and this one is another. And I want to split it at this continuity point. So we'll have two curves on the left, and we'll have two curves on the right side. This is one, and this will be a second curve on the right side if we split it at this continuity point. So this will be left 1, left 2, right 1, right 2. And our idea is to join left 2 and right 2 with left 1 and right 1. Once we have curves like that, we can join them. And the same, I mean, we can join them and we can create a loft. Same here. We'll have curve left 1 and right 1. There is no right 2 or left 2, and based on these two curves, once we have two curves inside the branch, we can create a loft. So now I want to find this continuity at each of these points. And based on the t parameter, I want to split left and right curves. But be careful with the data tree. 28 branches. Here we have 14 branches, which means we need to graft in order to get the same data structure. And now we can shatter. So what we get at 0, okay, I'm going to simplify. At 0, 0, 0, we get left 1, 0, 0, sorry, 0, 0, we have left 1, 0, 1, we have left 2. At 1, 0, we have right 1, 1, 1, we get right 2. But if you remember, I want to join left 1 with the right 1. So we need to modify tree structure. Before joining curves, modifying data structure, I want to make sure that we have, I want to make sure once again to set the right order inside each branch. So I'm going to find a middle point, and curves on the left, I want to sort based on their z, based on the z coordinate of the middle point. You can see here we have one item. That's because on the front part we have only left 1 and right 1, but in the second pair 1, 0 and 1, 1, we have two curves on the left and two curves on the right, and these guys we need to sort. You can see here this is one middle point, another middle point. So this will be left 1, this will be left 2, this will be right 1, right 2. So I'm going to deconstruct, and I'm going to sort based on the z coordinate. I will preview this. Actually, I'm going to take middle point. So what we have? The branch 1, 1, we have these two guys. At the branch 1, 0, we have, so curves that are closer to the corner will be 0, will have index 0. When I say close to corner, I mean to this corner here. So it will be 0, and here we have 1 and 1. So our idea is to take these two curves and place in the same branch. Take these two curves and place in the same branch. So that's why we need to modify data tree. If we take a look at this curve here and this curve here, or their middle point, I'm showing their middle point, they share the same main branch level, which is 0, but second branch level is different, and they share the same index item, which is 1. So we need to modify data tree, swapping, we need to swap second branch level. So this will be in the path mapper, we should have like this is original, and we need to place here A will be the same. So main branch level is 1, but the second branch level should be swapped with the index item. And here should be B. So we need to take this sequence and place in the path mapper. Okay. I want to ask, before I'm doing this, I want to ask you, is it clear what I just explained? Yep, sure. Okay. Now let's use path mapper. I will take these sorted curves and let's type here A, and I will swap with second branch level. And let's see what we have in the branch 0. The branch 0 we have, okay, for the first, for the front face, this is okay. But let's see here. These two curves are in the same branch, and this is what we need. I want to join them. And these two curves are in the same branch. This is also what we need. So I'm going to join. And now inside each branch, we should have a single curve. Yeah, single item. Perfect. And now we are going to trim tree. You can see for the branch 0, we have only one. We have only one branch that has main level 0, because we don't have like two curves. We don't have two branches, because these two curves are placed on the front, in the front. And also the same is for the okay, yeah, only for the 0, and the rest we're going to mirror. I mean, we're going to rotate or mirror on the other side. Okay. After we do this, I'm not going to join. If I join, then we cannot create the surface in front. So I will delete this, my mistake. We're not going to join. I will do something else. Okay. If not, we'll rewatch the video. Sure. So I'm going to trim 3 here. And branch 0, we have 2 items. So these 2 curves. But in the branch, in all the rest, all the other branches except 8. I will check what is 8. Yeah, 8 is on the other side. Yeah, of course. All the rest, except 0 and 8, we have 4 items. Which 4 items? This item. Sorry. This will be 1 item. This will be 2nd item. This will be 3rd item. And this will be 4th item. Sorry for these sketches. Maybe I can use middle point to visualize. Okay, 0, 1. But for the branch 1, we have 0, 0, 1, 2, 3. For the branch 2, here is 0, 1, 2, 3. What we need to do? If branch has 4 items, we are going to use partition list. And that branch with 4 items, we are going to divide, where this will be 1 branch and this will be 2nd branch. If branch has 2 items, we'll keep it like that. Same for the branch, let's say 2. Branch 2 has 4 items, and we'll divide that branch in 2. So instead of having 4 items in that branch, we'll split that branch, and we'll get 2 branches for that from that branch. What I mean, let me explain once again. If we have 0, 1, 2, 3, so 4 items from that branch, we'll get 2 branches. 0 and 1 will be in one branch, 2 and 3 will be in another branch. So let's calculate number of items. Here we have list length or number of items. So if it is equal to 4, those branches we're going to split with the partition list. Dispatch. So these branches, and we have another branches that we're not going to split. So 3 branch. I'll take these guys, and I'm going to use list partition. Separate 2, and let's see what we have inside each branch. These 2 curves are in the same branch. Now we can join them. And these, inner and outer curve. And I'm going to join them. The rest, these branches 0 and 8, I will keep. Okay. simplify. Now, finally, let's take a look at data tree. I will take this data, and I'm going to trim tree because I want to get only single level data tree, and each branch should have 2 items. Or 2 curves. Let's visualize. Okay. Branch 0 is this one. But let's focus on the branches 1 to 13 except 8. We have inner and outer curve, and we can loft. We'll get one mistake, and let me show you. One of these 2 curves needs to be flipped. So I will use list item, extract item 0 and item 1, and I'm going to flip one curve, and I'm going to merge them back, and we get the right result. And for the front part, we can simply, we already have like branches with 2 items, the same that we have here. But once again, one of the items needs to be flipped. Okay. Let's merge them. And we get 14 items inside each branch is a single surface. So you can see how we managed to get surface from the BREP, from the BREPs that we had before. Now we don't have any edge here. I will wait 1 minute for you to take a look at the script, and feel free to ask if you want me to explain some of the steps. In the final step, we need to split these curves to create frames, and that will be the final step. What do you think so far about this project? We have comment the manipulation of data structure. That was a question or your feedback? Yeah. Manipulation of data. I mean, if you understand how to manipulate with the data structure, your Grasshopper skills will skyrocket. Okay, no, wonder afterward you mentioned that this probably intermediate. Is it possible to show what will be advanced? You know why I said it's from the intermediate to advanced? Because some of our members or some of our friends from the LinkedIn are quite, master. I mean, they're masters in Grasshopper, and maybe for them this is intermediate. Maybe something with scripting in Rhino Common, Python, C#, creating like some custom components using Rhino Common. Maybe something like that would be something like that would be advanced. But yeah, I agree. This is kind of like for 99% of people is advanced.
I think Lazar is being a little bit modest, to be honest. So this is advanced. I wouldn't say it's intermediate, but Lazar is always setting the bar too high for himself. So that's why he's like this. So
Okay.
so yeah, Walter, like don't worry, like this is the advanced level. So after this, as Lazar said, it comes like the scripting, the writing of components in Python or in C#. And this is, like you don't need to get to this level. Like most of you will have, this knowledge will be enough for creating almost anything that you imagine. The scripting just comes after that if you want to even save more time with some tasks. And if you want to be more efficient in writing scripts. Sometimes people write components in Grasshopper because they are doing something like maybe in 5 steps, and maybe that one component can simply cut all those steps into one component. So essentially that's, I think, what's considered to be like, super advanced. Once you are mastering data trees, then you can kind of go into Python and C# because this is the next level after this. Yeah, so could you explain the difference between using only Grasshopper and using C+ and Python? So the same thing that I just said, right? So with C# and with Python, you can like create a script, create a component that does multiple steps just for one action, right? So in Grasshopper, you can do all of that, but you do it in multiple like ways, right? You can do it in multiple steps. When you're writing a script with Python or C#, you're actually trying to save time by creating a component that does a lot of things that you want to do, that you want to program, right? So sometimes when people are doing these very heavy complex buildings, in some cases they have teams of computational designers who are actually creating those Python scripts and creating Python or C# scripts that are only for that particular building that they're building, right? So if it's super custom, if it's super advanced, sometimes these we can also call them developers, like they're writing the code so that you can use that code only for that particular project. It doesn't mean that that component can be used in different projects. It can, but it doesn't have to. So I would say that's like the main kind of difference between using only Grasshopper components and then doing your own.
I would say like this. Using only Grasshopper, it's kind of you're kind of limited, because Grasshopper is based on the Rhino Common. If you don't know what is Rhino Common, just Google it. And you can, some of the components or some, say some command, you're kind of, if you want to do some command in Grasshopper, there is no component for that. But if you script based on the Rhino Common, you can do that. For instance, what I was maybe I was I think there is no project on mesh, project curve on mesh, something like that. A few months ago I was trying, and then there is like in Rhino Common project curve on mesh. I'm not 100% sure is it project curve on mesh, but I think it was that command. But in Rhino Common there is like library, and you can write like small, like in 2-3 lines of code in Python or in C#, and then component you can import in Grasshopper, and you can project curves on mesh. So what I want to say, you're using only Grasshopper, you're kind of limited comparing with knowledge of C# and Python and using library of Rhino Common. Hope it makes sense.
Yeah. Do you plan for the future to cover also other domains, not only architecture? I mean, I don't know, like we were mainly focusing on architecture, so we might at some point do something with Python and C#, but I'm not sure if that's, it kind of depends on you guys. It depends if there is enough need for this, if there's enough people who are interested in exploring different areas. Yeah. I remember some time ago you guys are working on Honeybee and climate analysis tools course. Is it still in your pipeline? Yeah, we haven't started doing this. We're actually doing some course currently, which is on optimization in Grasshopper in Rhino, and that's something that's gonna come up probably next year. We're not sure yet at what time, but we're working on the two big projects, which are going to be the big course for optimization for using evolutionary algorithms to kind of create the solutions for your projects based on, like, you probably heard of, what was it? Was it Karamba? No. What was the most common evolutionary?
Kangaroo.
Kangaroo, yeah. So we're gonna be showing. No, it's Galapagos. That's the one I was thinking about. So how to use Galapagos with creating some solutions that Grasshopper will automatically calculate for you based on the parameters that you give it. So you'll be able to actually have a set conditions for your projects, and you're gonna click one button, and based on your conditions and based on the parameters that you give to the algorithm will spit out the best possible solution that's going to be probably like the smallest price, the biggest, let's say, square area or things like this. So this is something that is really practical, that a lot of architects can be using directly in their workflow. So this course is coming next year, and also the course on digital fabrication and 3D printing. That's something that we have planned out.
Yeah, I was focused on I was thinking about the Grasshopper definition. I just realized what you asked me about evolutionary solver. Of course, it's in Galapagos. So I suggest to keep going, and once we finish, we can ask you. I mean, you feel free to ask anything related with this particular grasshopper definition or something else. What is our plan for the future, or whatever you want to ask. So once we get like single surface inside each branch, I'm going to merge them with surfaces that we have here before. So after we use match text, so all these surfaces on the bottom. So let's merge them together. And here we have all surfaces that should represent glass. Okay. And I will make a group, and I will call it merge side and top facade, glass facade. Okay. Now I want to make frames, and also to offset surface for that thickness of the frame. This solution or this approach, it's not the best, but I mean, probably there is some better solution for that. I tried with the offset curve on surface, but it doesn't work. So we'll need to find a way around. First, I'm going to extract all the edges. So let's flatten this. And let's extract, so I will use this surface, and I'm going to extract all the naked edges. So let's move this here. And what we need to do, I'm going to project these curves if we make this surface, if we make our glass flat. So I will take these naked edges, and I'm going to type project on a plane. So instead of having like curvy shape, I want to make them flat, or actually I want to extract only plane, vertical plane. So I will use evaluate surface. As I said, this is not the best solution. So I will extract middle point. So reparameterize and extract middle point. Okay. And this plane I'm going to use to project naked edges. Frame at, so this one. So now these naked edges are planar, and I want to offset them inside and project them back on the surface. And these curves I want to use to split original glass surface. Once again, I will take these projected curves, now they're planar, offset inside, and project them back here. But now I want to have the same offset direction. So if I use offset curve, so direction can be some small number. Let's say 0.2. So you can see here is offset outside. If I set negative value, Here is offset inside, here is offset inside. We just check all of them. It seems that at each surface we managed to offset inside with a negative. But sometimes offset is opposite. So sometimes curves will be offset outside. So I want to add that step just in case. And this is a nice trick to use in your workflow on another project. If you have this problem, sometimes let's say you offset the curve on the inside, sometimes is same curve is offset inside, sometimes it's offset outside, even though you set the same distance. What if we offset both sides and sort the inner curve again? That's what I'm going to do. I'm going to offset in both sides and check which area of the curve is smaller. So this is what we are going to do. I'm going to offset in both sides. Make sure to simplify. Have the same data structure. And I will check, let's say, maybe we can type larger or smaller, it's up to you. Which one is larger? And we're going to use pick and choose. Pick and choose. This will be 0, this will be 1. And you can see that, I mean, still there is no difference. They are offset inside, but I'm just telling you sometimes if you have multiple surfaces, you want to have like universal offset to, let's say, inside, but Grasshopper sometimes, offset outside instead of inside, even though you set the same offset distance. So make sure to add this step. Okay. And in the next step, I want to project them. So there is component project on project, this one. Here, curve to project. And we need to have B-rep to project onto is this one. So let's graft. And we need to know what is the direction, right? Direction should be should be normal. This one. I just want to make sure, yeah. But we need to graft also normals. Let's see if we got. So this is direction. This is surface that you want to project onto. Okay. Perfect. And now I want to split surface. Okay. So there is component split surface. This surface I want to split. Right? And I want to offset surface. I mean, here we get inside each branch we should get 2 items. Here we have, sorry, not curve, I should select surface. So based on this one, you're going to create frames, and based on this one, we'll make a glass. Okay. So I will keep this one, and I want to push the surface inside. So I want to move it inside, but now to move it inside, I need to know what is direction. Direction we have here, this normal direction. But let's also try to unify this direction, these vectors. So let's use display vector. Okay, here is a problem that we can get. You can see some vectors go outside, but some vectors go inside. So I want to unify all vectors to go either inside or all the vectors go outside. In order to fix this, one more trick, I will take this point, so all the points, and I want to find average. Okay, and I want to move these points along along normal direction and also along reverse normal direction, and see. So basically for the single point we'll get 2 points. One point will be moved along normal direction and one will be moved along opposite normal direction. Once we get 2 points, we'll get which of these 2 points is closer to the average. And in that way, we're going to make a pattern which direction we're going to choose. All right, so let's graft each point. And let's graft all normals. So I'm going to move point. Here we get vector, and I will add different amplitude. So for each vector, I will add positive and negative value. Let's say 0.3. So negative and positive value, which means each of these points will be moved along positive and negative normal direction. We get 2 points, and these 2 points I'm going to for these 2 points I'm going to calculate distance to the average point, this one inside, and I will say, okay, sort these vectors based on the distance, and this vector we're going to use, I mean vector with the index 0 we're going to use. Is this part clear? This is very important, so because many times in the future you're going to use this trick. One point placed in a separate branch, use positive and negative vector, normal vector, to move that point. So we'll get 2 points and calculate the distance to some central average. Which point is closer? You're going to sort these vectors. Let's use vector display. Going to flatten. And let's see. So now all vectors go inside. And these vectors we are going to use to move our glass. So I'm going to move. Let's graft. So we push the glass inside. And also I want to extract both of the edges of the frame surface, and I will select smaller one. Yeah, this surface. So yeah, I'm going to outline. I will take outline of the surface, this glass surface, and I will take outline. Here we also can get outline, and I will use a rule surface to create the depth frame. So I'm going to merge them. Let's make sure we have the same data structure. Inside each branch, 2 items, brep join. Okay, so here we have frames. And here we have glass. That will be all, guys. I think we're done. So we managed to create all facade glass panels with the frames.
Showing the other view.
Monochrome. Yes, but maybe we need to bake it first. Not this one. I mean, we can take this one. We can bake. Let's bake this geometry. So this one will be baked. Top facade element. This one will be baked. Glass. I mean, frames. Glass. Oh, maybe I should close Grasshopper. Yes.
There it is.
There it is. How many? Yeah, it will be in total 9 hours tutorial, I think. So 3 times 3 hours.
Yeah.
So what do you think? Do you think it was too complex? Yeah, I suppose we were going to rewatch, and once you rewatch, feel free to post the questions in our school, and also feel free to ask us right now if you have any questions related to this script. Yeah. Whoa, cool.
Yeah. This is nice to be animated. Cool, nice action.
Beautiful. Would this be the same process to move the glass to different location to the structure?
I think this depends on the location of the structure. Like this glass was created specifically for this structure, but if you have different type of building, you would have different type of data tree for that building. So this was specifically done for this shape, but of course, the whole idea about the tutorial was to show you how you can manipulate data trees and how to be able to do this yourself with your projects, of course. 3D print, yeah, this is actually a good idea. We can 3D print this. We should do a 3D print.
Yeah. Why not? Let's check.
We can do even like a bigger model. We can do the maximum size, 25 centimeters. It would look cool.
Can you move clipping plane using Grasshopper? I'm not sure. Did they implement clipping plane? I know it wasn't implemented. I'm not sure. I think we still don't have clipping plane.
So, for example, this is an excellent idea for somebody to develop like a Python or a C# component for Grasshopper that can do the clipping plane. So this is the idea of like we talked about this earlier. Like if you don't have something in Grasshopper, there is probably a Rhino common command for this, and you can create these new components in Grasshopper if you need them.
Yeah.
So yeah, maybe this is a cool challenge. Maybe we can in one of the future tutorials, maybe we can do one component in Grasshopper.
For the clipping plane.
Yeah. Or something else.
Yeah, for sure. You can reference it.
Awesome. Cool. So now guys, if you have any additional questions, let us know. A little bit earlier, we started to discuss some other things. Now you can also ask anything else that you want.
Yeah. I'm afraid there is no questions related to to what we've done today.
The project.
Yeah, for the project.
So Happy Time says there is a way to do this with Python. So for sure, probably there is a way to do it. You can, if you want, you can share this in our community on School. Can you put a link for the community?
Yeah, sure.
So you can share this if you want with the community in our group, and everybody else can also see it. Just go there, it's free. And we're also gonna publish material on there. So can you tutorial explaining all the components in sets? Well, this is something that we have actually in our course, Grasshopper Complete course. So we actually explained all of the almost like 95% of all of the components are explained in great detail in our Grasshopper Complete course.
Yeah.
So if you guys want to learn Grasshopper starting from the ground up, that's the best option. What we show here on YouTube is a little bit more complex, more advanced. But if you want to start from scratch, you should this is like definitely a good option. Yeah, thank you, Walter. Yeah, I was here next to Lazar on the separate table because I wasn't needed at the time. Now we're gonna close it up. So yeah, that would be all, guys.
Yeah.
Once again, thank you for joining us. Thank you for staying with us. We have around 25 people that stayed until the end.
24 right now.
So hope that you learned a thing or two about data trees and manipulating this in Grasshopper. For those of you who are not familiar with us, you can join us in the link that we just have, school.com/howtorhino. That's the best place to interact with us and also to join the community of other architects who are learning Rhino and Grasshopper. And we have a lot of free resources, additional resources there. And yeah, that would be all. I would also invite you to maybe check out How to Rhino Premium, which is maybe you can.
Do you want to share it about the upcoming workshop?
Yeah, so let me just open up my window here. So so this is our How to Rhino community on School, and once you join, you'll be able to interact with us. Here we have a lot of people asking questions. We have a lot of other architects helping other architects. So it's really good to be a part of this because if we cannot help you directly, somebody else will jump in and help you out. And in the How to Rhino Premium group, which is the group that is paid, we have a lot of workshops coming up. So the next workshop we have is on D5 for architecture this upcoming weekend. It's going to be with Andy Cristoforo, and we're going to talk about how to use D5 for architecture. This was the tower that we just did now. So all of the project files will be available in the premium group as well. And of course, you can also purchase all the individual mini courses and workshops from the previous months. But if you join us now, you will have access to these available things in November. And in the next months, we're going to have other workshops and other mini courses that are coming up. So I hope that that was clear. Yeah, that would be it. I would close this with.
Thank you also. I want to say thank you for staying with us, not just today, but thank you for everyone who stayed all these 3 days with us. So in total, more than 9 hours.
Yeah, more than hours. And yeah, thanks God we didn't have any problems with the sound.
Yeah,
finally. So I think we solved that. So yeah, once again, thank you guys. And we'll see you in some other stream next time. Bye-bye.
Bye-bye.